And welcome Robert Kosara.
Thank you. I want to talk about what we do at Observable with DuckDB. We've been using DuckDB in lots of different ways for a while, and so I want to give you a little overview and also show you how we use DuckDB for things that are very fast and how things could be even faster. And I have a little wish list about that. And I took some pictures about a month ago in Katmai National Park in Alaska, so you will see some of those. I figured nobody else would have the idea of taking, having duck pictures on their slides. So I figured this would be very original. But anyway, so this is the agenda here. I'll talk about notebooks. If anybody knows Observable here, you probably have heard of Observable notebooks. I'll talk about the Observable framework. And then we built a customer proof of concept recently where we've learned a few things about DuckDB. So we'll talk about that. And that will bring me to our wish list and then some conclusions. So the first part of this is going to be a really quick sort of like intro to or like idea of what notebooks look like in Observable. This is an example of a notebook. This is a little test data set that we've built about a fictional pizza chain called Pizza Paradise. And this notebook is a computational document. So you can, and this works right in your browser. So I didn't take a screenshot of the whole window here, but you have to imagine this living in your browser. And you can have text there. You have these cells on the bottom that have like JavaScript or SQL or other things like that. So you can do computation right there, and it all runs in your browser right there. Like there's no backend that it has to send its queries to. It all runs right in front of you on your local machine. And as we've seen, our machines and our browsers and our browser engines are just incredibly powerful these days and are able to handle lots of data and are really fast. And so with database, or with DuckDB, I guess in particular, we can do queries right there in the browser. This is just a simple query just to, I think, look at locations where customers live or whatever in this fictional pizza chain. And that gives you a little table that in itself is a little interactive tool. So it's a table that you can sort, that you can use these histograms to filter and so on. And what you can do with that is you can name that, and then it becomes a variable, and that variable can be used to do other things. Like, for example, you can plug it into Observable Plot, and you can make things like maps. So this pizza chain has all its locations in California and Nevada for some reason. Or you can make weird maps, like this Voronoi diagram. And so all of this is possible right there in your browser, and it's all easily doable given the power of DuckDB to a large extent. So the DuckDB client is part of our standard library, which means you don't have to import it. It's just right there. You can just use it. We use this for data wrangling and querying. I was a bit worried about mentioning CSV here, but apparently that's a thing that people do. So a lot of people do that in Observable. We do it a lot. We use a lot of CSV files, and then they turn into something better. But we do cleanup, we do querying for cleanup and aggregation and joins and so on. And we can use this from the data table cell, which is an interactive cell that you can do like your manipulations in without having to write SQL, and then you can turn it into SQL if you want to, and work from that and plot as well. And it's ideal for running in the browser, as I guess everybody here probably knows, but with WASM, it's just super easy to load DuckDB and handle millions of rows right there on your little computer. And it's just performant. And I'll come back to this a few more times because there are a few more use cases for that. But more importantly, I think I want to talk about Observable Framework, which is the more recent development where we build data apps and dashboards using a static site generator. So the way Framework works is that you have a machine somewhere in the cloud, and there's a build process. So I kind of assume most people here know what a static site generator is, but the idea is that you have data somewhere in a database. Maybe you have some more data on disk, and you have scripts on disk and stuff like that. And you query your data, you run maybe very expensive models. You might be querying APIs that are very slow, but you might be querying a database that is very slow. And all of this happens offline and creates a little package of data and code and stuff. And now when your user comes along with their web browser and requests this dashboard, this data app, all we have to do is grab our package and just deliver it to the user, and they get an instant dashboard. And so that way we can load much faster and be much faster to deliver a valuable and useful dashboard than most traditional BI tools. And of course, this doesn't mean you can't use a database. You can still query, especially things like Snowflake and any of those databases that are available through the web, but or through, I guess, that don't live like on premises. But of course, this is also true for DuckDB instances that might be living right in your browser or that come with the data package that you've downloaded from your server. So, which is what I'm going to show you in a little demo. So this is an example here of a framework document. On the left, you see the source code, and on the right, we have the rendered output. It's not very exciting yet, but this is just Markdown. So let's see if I can actually type. And once I save this hot reloads on the right, and you can see the output. More interestingly, though, I can create some things. Again, this is a Markdown file, so this has this thing called a front matter, and I can create a table, or I can import a file and declare this to be a table in my instance of DuckDB that has just been created because I just wrote that little SQL thing at the top there. And what I can do now is I can start querying that. So I can write a little fenced SQL block, and I can write some SQL, and we'll see how well this works, but let's just do this from languages. So here I have my little query that you just saw me write. I can actually do this thing here. So I can see the query, and I'm going to zoom in here a little bit. I hope, even on this giant screen, well, actually, this is a very giant screen. I hope you can see this. So I can query, and which is not that exciting because, but just very quickly, this is a data set that comes from Eurostat, from the European Union. It's about language teaching in different countries. So we have a field here called CHIO, which is the country where this language is taught. So Austria here, France, and so on. And then we have a time field, which is the year. And then there's the actual variable. Oh, and I guess the language. The language is in this field here. And so we can make a chart out of this, and we can make it interactive. And I want to show this very quickly. So to do that, I can now use some JavaScript. And the power, I think, of Framework is that we can combine SQL and JavaScript very seamlessly. So I can do something here, like I can make a variable that is really a constant. That is, I'm going to use a library here called Observable Inputs. And it's just going to create step size 1 because we want full years. And this creates a variable for me that's just going to respond to this range slider. And now I can use, so this year variable here, I can now use to say, what's this called? Time period equals the year. And so now, all of these values here that you see are filtered down to the value that I've selected in my range slider. So as I change this, you can see that change here on the right. And so we're going from JavaScript to SQL, and we can go back by naming this cell here. So I'm going to say ID here. I'm going to call this 1 year. So we're just going to select 1 year of our data, which makes it disappear. But I'm going to take my cheat sheet here and just copy over some code, because you're not going to want me to actually type all of this now. But I can now make a chart that uses that same variable 1 year here, which comes from over here. So this is the output of that SQL cell that queries data based on my range slider, and then responds and puts out data that then goes into plot, and observable plot then renders this. And so whenever I change this, if I can actually grab the handle, it now reruns this query in real time, and you see the output. So this way we can build, and you can imagine this whole thing running in like multiple cells across a large dashboard, and building things that we can, that make an interactive dashboard running on data that lives in your browser. So what we do in Framework then is we have the SQL front matter to load CSV or Parquet or DuckDB files directly, just by declaring that, just by saying, hey, I want a table up here, or a table that's loaded in here that creates tables in DuckDB. And then I forgot to show you the important part here is, of course, the data loader. So this file, and it was complaining about this earlier not existing. I'm not sure why exactly, but this file doesn't actually exist. So that was the whole point of this. And so what we do here is we actually have a data loader. So if you see this edu something something language or one.parquet.sh, what happens when we look for this file, not in my cheat sheet, but here, then this something.parquet file, what Framework does is it looks for a loader that could create this and looks at its extension. In this case, it's a shell script, so it's .sh. This could be R, this could be Python, this could be Rust, it could be anything really. And then runs that, and then the output goes into our dashboard. This is, I don't want to talk about any details here, but this downloads this file from Eurostat and then caches it because it's a very slow API, and then runs it through DuckDB for some data munging. And you can see that here we get the input from the CSV file, and then the output is this Parquet file that is the output of this script. And if it's a build, we actually materialize the file. When it's just running in the development server like here, we don't, because what I can do here is I can, for example, uncomment this line here and make all the data disappear, because now we're only looking at 2019 and I have whatever 2017 filtered. But you can see that it watches all these files, and any changes re-trigger everything being re-rendered and rerun. So yeah, so this re-triggers the data loads as I just showed you, and we can easily query using these fenced SQL blocks. And of course, we use it in data loaders, as you just saw in my example here, for large files that we load and that we wrangle. And it's tied into Observable Plot very easily, because we can just take the outputs of all these queries and pump them into Plot. And we use it extensively in this large customer proof of concept, which I will talk about next. And starting with this image that I call all the ducklings in a row. So this POC was for a customer who is a large analytics company in a specific industry with a large number of clients themselves. And they want a better way to show their data. So what they have right now is slow and clunky and kind of ugly, and they want something better. But what they need to do is they need to separate the data for all of their customers. So they have, for this POC, we had a few hundred, but they want to eventually have thousands of customers on this system. So we need to be able to do that. And each customer has a reasonably large amount of data. So it's in the millions of rows for most of them. And initially, so this was built over months or so. The idea was to just query all the data using DuckDB and then do all of the data munging, all the transformations in JavaScript. But then, and this is a quote from a document that my colleague Phil Riviere wrote, he said, "I went for a walk and came to the realization that I just needed to trust DuckDB." So I felt this would be sort of like the message for this kind of audience here. And so what we do is we have this kind of build step, like as I described earlier. So this is the static site generation. Then we have the server that is the web server for this whole thing. And then we have a client. And the build runs a large number of data loaders that they all use DuckDB. It's basically the same way I just showed you, just slightly more complicated scripts. And then they generate a number of files, including a file called initial.json, which I'll talk about in a little bit, and then a number of tables as Parquet files. And on the client, we have this DuckDB instance that you saw that I created with that front matter, and a number of views on the dashboard. I can't show you the dashboard, but it's just imagine a great dashboard. It's beautiful, lots of views, lots of interaction. And whenever you interact with that, it then queries the database. And this had to be debounced for reasons that I'll get to in a second, because we can't quite run these queries at interactive speeds, not yet anyway. And so what we found was that for faster loading, we actually had to generate a small file, this initial.json file, to load that and render the dashboard first, and then bootstrap DuckDB. And sort of rehydrate the dashboard from there with the actual data, and then be able to interact and requery from there and actually show the results. And the interaction, of course, drives these database queries. But as I mentioned, we had to debounce that because the interaction is supposed to run at about 60 frames per second, which the which DuckDB doesn't quite do for these data sizes, but it's kind of an interesting thing to think about. And I have a wish on my wish list for that. And then also, as I said, we have DuckDB and we've been using DuckDB very extensively in the build process and processing large amounts of data. So this is actually coming from a very large backing store that gets queried. So this is certainly big data, but yeah, every individual customer that we built for gets a very small slice of that because we are looking at a large number of customers for a customer. And that brings me to my wish list and also the unfortunate image here, because I was hoping that Richard Wesley, my former colleague at Tableau Research, he always had fish on his slides, and so I was going to put this on there just for him, but he no longer does that. So just it's his fault. But this is since I was a Katmai, I figured this would be the more appropriate image to show you. The ducks there were cool, but the bears were cooler. This is not a statement about DuckDB. I just think this is kind of a thing that's true. I shouldn't. I'm kind of talking myself into a corner here. So let's get to the wish list. So the things that I thought I would bring up here, because I figure the right kinds of people are in this room. One thing that's interesting that we found that we kind of ran into is that it would be nice to have support for rehydration. And what that could look like, perhaps there would be a way to sort of materialize the results of a query, just to have that as a first sort of like thing that you can load quickly to then be able to draw or to like render things on a dashboard or in a data app. And this could be part of the DuckDB format, perhaps. We did it separately because we were using Parquet, but of course we didn't have that feature. Debouncing is a big deal. This was important for us because it was very easy to move a slider back and forth and just end up thrashing in the database and just not get responses back. And so what we did was to basically gate this ourselves. But it'd be interesting to see if it's possible to have like a prepared query with parameters that you pass in. And when you re-trigger that query, if there's already one running, then you just kill the previous one, or you decide to kill the new one, I guess, and just to keep the other one running, something like that. But it could be interesting to think about like ways of debouncing queries in DuckDB. And then DuckDB Wasm is awesome, but it actually turns out that it takes a little bit of time to load still, and it's still faster to not load it. And so, if it's possible to decrease the size of the client, I don't know if that's possible or not, but that would be one thing that would be great, or to modularize it to get to be able to load just the first part and then load on demand, perhaps load things that we need later. And then the last thing, and this is very much a thing that just happened during that time period, I think. This was just as DuckDB 1.0 was being finalized, I think, that the file format was kind of not stable or not able to read some of the older files. I forget what the exact problem was, but so always having a way to not have to rely or to fall back onto Parquet would be great, because this was a bit of a problem where we had to then basically work around the DuckDB format not being entirely stable at that point. But that's my entire wish list. And with that, I was going to say, so what we do at Observable is we use DuckDB in Observable notebooks. We use DuckDB in data apps. We use it for data loaders. We use it on the back end, on the front end, for early exploration, for development, in production use, and everywhere. So with that, I appreciate your attention, and I'm happy to take any questions.
Thank you, Robert. So number 4 on your wish list has been fulfilled already with 1.0.
All right.
We have a stable storage format. So.
Oh, yeah, right. This was perhaps, sorry, I should have, thank you.
No worries.
I appreciate that.
That's taken care of. Any questions from the audience? Yeah.
Thank you. That was a great talk. I'm just wondering, I just have a question about the user experience of the observable framework. So when I assume the framework is kind of like, is it a JavaScript framework or, right? So if I download that framework, do I have to do all the setup with DuckDB myself, or is it shipped with DuckDB in it? And I think the follow-up question to that, is there any way I can replace DuckDB with another database option of my own?
Yeah. Are we allowed to talk about the last part? To answer your question, so yes, it is JavaScript on the front end, but the back end, the data loaders can be anything. Like you saw the shell script, you can use Python, R, whatever you want. So it's very much meant to be polyglot. So you can use any language for the data loader part, but anything that runs in the browser is going to be JavaScript, at least for the moment. It comes with DuckDB fully like packaged. So that's what I was trying to show you here, is that if you just simply, because this is basically out of the box. Let's just look at the cheat sheet. It doesn't matter. So this is just a declaration in a standard Markdown file that just has that built in. And so whenever I just import a file this way, that generates a DuckDB instance. But you don't have to use this. You can use your own DB client and then just connect to it whatever you want. It could be Postgres. It could be Snowflake. It could be anything. And that's true both from the browser and from the data loader. So no matter which part of it is, you can always talk to any database you want.
Cool, thank you. There is another question here.
Hi, great talk. You mentioned that you have doing a proof of concept for hundreds of clients, and the clients have millions of rows or something like that. Did you ever cross a problem with having a single table with millions of rows and rendering it on these renders that you were like this? How did you solve for that? Like the millions and millions of rows in JavaScript being managed for the plotting?
Yeah, so we do that because there is a sort of like an overview dashboard that covers everything, and that has all the data that's inside the scope of this proof of concept, which is, I don't know, it's a much larger number. It's like tens of millions of rows. But that has not been a big problem, so we can certainly do that. The actual, I don't actually know what the data file size is, but it's not even that much to download in the end. It just takes longer than we wanted to, but you can definitely do that interactively. That is not a problem. I mean, interactively, there is a fraction of a second of wait, but it's totally usable.
Thank you. Next question.
Hi, thank you. Some of the stuff you're doing crosses over a little bit with the Mosaic demo that was given earlier. And under the hood, Mosaic is actually sort of like a superset of Observable plot. And I'm curious if y'all at Observable are sort of working on something similar and are collaborating or are not collaborating. A lot of the stuff you are speaking to about like debouncing queries and interactions isn't Spirit kind of the goal of that. And I, have conversations about Mosaic a lot recently, and like I'm kind of seeing that 2 or 3 of us are working on the same thing. So I'm curious if there's like a working group that I'm missing too.
Yeah, I'm not sure I can tell you. There's not a lot that we do specifically, but I think we're very much fellow travelers. So yeah, so Mosaic is built is sort of like a re-implementation of sorts of plot. It's based on the same kind of architecture and grammar, certainly. And we certainly, and yeah, it's actually a good question. I don't know how the debouncing works there. I haven't looked at it. I don't know if the people who built that proof of concept actually had looked at that to sort of inspire their approach. It's a good question, and I don't know if I have a good answer to it, but we certainly have very similar sort of like things that we do, and we are certainly very much aware of Mosaic. So Mosaic is one of the demos, actually. When you go to the Observable Framework website, there's a Mosaic demo in there because it's very much in the same spirit of building things that run in the browser and deal with large data sets and are interactive and super usable just right there in the browser.
Hi, in your intro slides, you mentioned something about having like data packages and static typing. I didn't really see that in the demo. I was wondering if you could explain that, sort of where that fits into the architecture, because that wasn't particularly clear.
I'm not sure about static typing. I did talk about a data package, I guess. So what we do is, let me see. I think what you're talking about is actually this is also here, because we materialize these files. So in the actual build process, so what I showed you interactively was just like re-rendering and rerunning all these scripts. But in a build scenario, we materialize these files, and this is what I called this package earlier, where we package up these files. These are output files that are much smaller and much more processed than the original data that this comes from. This I'm pointing at this this middle column here, and then that is the stuff. So the client, when the client requests the data app or the dashboard, this is what they get. So they don't talk to the back-end database directly. They talk to this, and this is a much more condensed, much more optimized version of the data, and just the data that they need and nothing that they don't need.
Okay, thanks.
Does that answer your question? Okay.
I misunderstood.
Okay.
Cool. Thanks so much. Thanks again, Robert, for the talk.
Thank you.
And let's move on to the next one.